Sanbolic's Melio 2010 product suite consists of a clustered file system, a clustered volume manager, and application clustering software for Windows Server 2008 R2. By utilizing this software, users can provide active-active storage access to a volume, distributed snapshots, quality of service, and performance reporting. This can be used with Hyper-V, IIS, SQL Server, clustered file servers, and both physical or virtual environments. System Center Virtual Machine Manager and Windows Failover Clustering both support Melio 2010 as an active-active storage resource. Melio also has hundreds of perfmon counters that can be used by System Center Operations Manager for reporting. Additionally, DPM can invoke Melio's distributed snapshot to centrally back up Hyper-V and SQL Server environments. Melio can be used to provide additional storage functionality to Hyper-V, such as centralized backup, quality of service, and support for large, high-performance clusters. Users can also use it for storage consolidation and dynamic load balancing of SQL workloads, creating clustered file or web serving environments, and for providing high availability for Zen Desktop or App-V. In the following demo, I'll provide a brief overview of the La Scala Volume Manager, shared access to a volume using Melio, quality of service, System Center Virtual Machine Manager integration, and snapshots. This is the interface for the La Scala Volume Manager. The La Scala Volume Manager is used in place of Windows Disk Manager for the disks that you want to provide shared access to. Additionally, instead of formatting the disks with NTFS, they are formatted with MelioFS. By doing this, users can provide concurrent read-write access to the same volume by multiple hosts. The main difference between La Scala and Windows Disk Manager is that La Scala is cluster aware. It is aware of all servers that share access to the same storage resources. By being cluster aware, anytime you perform a volume manager operation, such as creating a basic partition, once that operation is applied, it is instantly seen by all servers in the cluster on the fly. There's no user intervention required, and you do not need to go to the other servers and rescan the disks for changes. On the left here, we'll see a listing of servers. This allows me to select other servers in my cluster and see their local volume manager interface as if I was actually on that system. Now the storage view here looks the same because the same disks have been presented to all four of these servers, and we can see that it sees the basic partition that I just created. I did not have to do any rescans. If you're running multiple clusters, you can add in other systems to this view that are not part of this cluster. That can be done by doing Select Manage Computers and having La Scala go out over the network and scan for other systems running the La Scala Volume Manager. Once it finds systems running the La Scala Volume Manager, you can add them into your view. La Scala also supports the ability to create stripe sets, allowing users to create a stripe across multiple storage controllers to aggregate their bandwidth. Additionally, mirror sets can be created across multiple storage arrays so that users can sustain an entire array failure, but their applications will still have access to the data. La Scala does this using only basic disks. There are no dynamic disks within La Scala, and these can be used in conjunction with failover clustering and Hyper-V. La Scala also supports the ability to expand volumes on the fly. This can be done at the hardware level if you have storage that supports back-end volume expansion, and then we can dynamically expand on top. Or you can present a new LUN and use that unallocated space to expand a volume. Or in my scenario here, where I just have some empty space at the back end of this LUN, I can go ahead and create a new partition, take this partition and drag and drop it into an existing volume. Now this is an on-the-fly volume expansion. There is no I/O interruption. And again, because we're a cluster-aware volume manager, all servers will see this expansion without any user intervention. Now you notice these operations will show up in blue. This is because La Scala is a transactional volume manager. That means I can queue up a bunch of transactions and then apply them all at once in bulk. When something shows up in blue, this is essentially a preview mode. You're seeing how it will look if I was to apply these changes. So if I decide that there's something I don't like, I can use the standard Control-Z and actually step back through each one of these transactions. Additionally, we've integrated Windows ACLs into the Volume Manager. This allows you to use ACLs to control whether or not a server can even mount a volume, or maybe it mounts this volume but in a read-only mode. You can also control this server's permissions over the volume from within the Volume Manager. Can it delete a volume? Can it expand a volume? Can it change the permissions of this volume? Etc. The Scholar is a 64-bit volume manager, so it does support LUN sizes up to 18 exabytes and creating individual volumes up to 18 exabytes as well. Now, as you see here, I have 3 volumes. They've all already been formatted with Melio, and once formatted with Melio, all servers have concurrent read-write access to the volume. We can see from this server here, it sees the M, X, and S drive, and we can also see that from this server here as well. Now, Melio is a 64-bit symmetrical clustered file system, so it will support file system sizes up to 18 exabytes and individual files up to 18 exabytes as well. It's a symmetrical file system, so there is no metadata controller, there's no coordinator node, there's no management server, there's no one system that needs to be online and connected for all the other servers to have access. Every server is independent of each other, and all servers use their block level connection for both user data and metadata. This essentially allows for any server to come and go from the cluster as they please, whether that's gracefully or ungracefully, and they're not going to affect the access or I/O to any other servers in the cluster. Additionally, Melio has quality of service components that allow you to set minimum bandwidth guarantees at either a server, application, or file level. Setting minimum bandwidth guarantees at an application level allow you to ensure that performance will not be degraded to these applications by other storage operations. Now, this minimum bandwidth guarantee only goes into effect if these applications are actually running and they're performing I/O against the file system. The per file name quality of service works on the same principles, except I can browse to the Melio file system and actually select a specific file. Now, this is a Hyper-V environment, so I'm going to go ahead and select a VHD, and now I can give this specific VHD or this VM a minimum bandwidth guarantee. Now, if you don't want to apply it to a specific VHD, but VHDs in general, we do accept wildcards, so you could say star.vhd, or maybe you want it to apply to all of the Hyper-V files. So you can actually go to the volume, and I keep all my VMs in this VM subdirectory, and I can actually select this directory, and now it'll apply to any files located underneath that. So this will apply to the VHDs, the SVHDs, bin files, XML files, all the files that make up the virtual machines. Melio also has its own VSS provider that allows you to take distributed snapshots of an entire cluster. The VSS provider can be invoked from any member of the cluster. Once invoked, that server will synchronize all other hosts in the clusters so that they do a synchronized flush to disk to get the file system in a consistent state for a snapshot. There are 3 ways to invoke our VSS provider. One is through the command line. The second is through a third-party application, or through this user interface that we provide. So I can just select a volume here, say create snapshot, and now that we have a snapshot, I can go ahead and access that snapshot for its data. Additionally, if I want to give access to the snapshot to servers that don't have the block level connectivity, I can mount the snapshot as a network share. Now, since this snapshot is in the file system itself, it can be accessed by any member of the cluster. It does not have to be the server that created it. When virtual machine resources are brought into failover clustering will look for the disk signature of the volume that the virtual machine is running on. If it detects that it's the Scala disk signature, it will automatically configure the virtual machine for an active-active storage resource. Additionally, all of your functionality within failover clustering will continue to work, such as live migration. For users that are using System Center Virtual Machine Manager to manage their Hyper-V environment, that is also supported. All of your functionality within VMM that you would normally use will work just the same with the Melio Volume. For more information, please contact sales@sanbolic.com.